All right, let's jump right into one of the most famous and honestly most misunderstood ideas in all of science. We're talking about Schrödinger's cat.
I mean, you've heard this a million times, right? The cat is supposedly alive and dead at the same time, until you peek inside the box. It sounds totally nuts, but what's really cool is that the real story, the why behind this whole thing, is way more interesting than just the paradox.
And that's our mission for the next few minutes. We're going to break this whole thing down. And I promise, by the end of this, you will finally get what it's really all about. No equations, no headaches, just plain English.
Okay, so to really get the cat, we first have to understand the problem that made Schrödinger dream it up in the first place. And for that, we have to shrink way, way down to the quantum level. And trust me, this is where things get, well, really, really weird.
At the heart of all this is one crazy idea: superposition. Think about it like this. You flip a coin. While it's spinning in the air, is it heads or tails? Well, quantum physics says, for a tiny particle, like an electron, the answer is kind of both. It can be in all its possible states at the same time, spinning left and spinning right. It's not one or the other. It's in this weird, fuzzy, in-between state until the moment you measure it.
And that right there, that's the big problem. You've got this wild quantum world of tiny particles where these bizarre rules apply. But then you have our world, the everyday world of big stuff, baseballs, cars, and yeah, cats. And in our world, things are definitely in one place at one time. My keys are on the table. They are not also in my pocket. There's a huge disconnect.
And this is exactly what drove the physicist Erwin Schrödinger crazy back in 1935. He's looking at the superposition theory and just thinking, come on, this can't be right. What happens when you smash these two worlds together? When the weird quantum world has to interact with our normal, everyday world? And that question is what leads him to his famous thought experiment. Now, this is maybe the most important thing to remember. He wasn't trying to say this is how reality works. Not at all. He was basically making up a crazy story to make a point. He was protesting the theory, showing just how ridiculous it sounds if you follow its rules to their logical conclusion. Yeah, his whole plan was to take this strange quantum rule and blow it up to the size of our world, to see if it would break. He was trying to shine a giant spotlight on what he thought was a huge hole in the whole theory.
So here's the setup for his little story. First, you take a cat, don't worry, it's just an imaginary one, and you put it in a sealed steel box. Inside with the cat, you place a single radioactive atom. Then you hook that atom up to this Rube Goldberg-style contraption. If the atom decays, a Geiger counter clicks, which triggers a hammer to smash a vial of poison.
Okay, you ready? This is where the quantum weirdness really takes over. That single atom, it's a quantum object. So according to the rules, after a certain amount of time, it's not decayed, and it's not decayed. It's in a superposition. It's both, decayed and not decayed at the exact same time. Just a fuzzy cloud of probability.
And here it is, the punchline of his entire argument. He says, look, if the atom is linked to the poison, and the poison is linked to the cat, then the fate of the cat is directly tied to a quantum event. The whole system is connected, which means if the atom is both decayed and not decayed, then the cat must also be in a superposition. Mathematically, until you open that box, the cat is both alive and dead.
But let me say this again, because it's so important. Schrödinger thought this was complete nonsense. He wasn't suggesting this is real. He was basically shouting, see? Look at the ridiculous place your theory takes us. Obviously, a cat can't be alive and dead, so your theory must be missing something.
So, what's the solution? If Schrödinger was wrong about the theory being flawed, how does modern physics get us out of this paradox? Why don't we see half-dead, half-alive cats walking around? Well, the answer is a process with a really cool name. It's called decoherence. And here's the simple way to think about it. That quantum superposition state, it is unbelievably fragile. It only works if a particle is totally isolated from everything. The instant it bumps into anything else, an air molecule, a stray bit of light, literally anything in its environment, that interaction forces it to pick a side. It has to choose a single state. That collapse is decoherence.
So let's walk through what's really happening inside that box. I mean, this process is lightning fast. At the very start, sure, the atom is in superposition, but a tiny fraction of a second later, it's inside a box with, air and a cat and a detector. It's constantly interacting with its environment. And those interactions force the decision. The atom collapses into one state almost instantly. The universe, in a sense, has already looked at the atom way before we ever get a chance to open the box.
And that's the bottom line. The cat was never both alive and dead. It's just way too big, too complex, too messy. The environment inside the box forces a single reality to emerge almost immediately. It's either decayed or not, dead or alive, one or the other, period.
Okay, so let's wrap this up. What's the real point of this whole story? What did Schrödinger actually want us to take away from this?
Actually, before I tell you, try this yourself. Just pause for a second. Can you explain the whole point of Schrödinger's cat in just one sentence? It's a fantastic test to see if it clicked.
So how'd you do? Here's my version. Quantum particles can exist in multiple states at once, and Schrödinger made up the crazy story about a cat just to show how insane that idea sounds when you scale it up to our world.
So, the big lessons here are pretty clear. 1. It was a protest, not a physics lesson. 2. Superposition is real, but it's for the tiny quantum world only. 3. The environment immediately forces one single outcome through decoherence. And 4, maybe most importantly, no actual cats were involved. It's a thought experiment.
Which kind of leaves us with a final fascinating question. Schrödinger created this experiment to prove quantum mechanics was incomplete. And in that sense, you could say he failed. The theory held up. But at the same time, he accidentally created the most powerful and famous example of quantum weirdness in history, one that made generations of scientists really think about this stuff. So was it a failure, or maybe the most successful critique of all time? Kind of makes you wonder, right?